So my name is Nyah Macklin, and today we're going to be talking about architecting context, how to structure your knowledge to make your agents smarter. All right, so I'll just start off with a little bit about myself. So again, my name is Nyah Macklin. I'm a senior engineer and a developer advocate for artificial intelligence, and my research focuses on graph theory, graph algorithms, and context engineering while understanding the very architectures that are best used to break open this black box concept or phenomenon, and to be able to decipher and trace and explain how artificially intelligent systems work. So it's also my core philosophy to think critically about the technologies that we all use every single day and promote as well. So I also center ethics and governance, safety, as well as responsibility in my conversations around artificial intelligence. So today, we are going to crack open that mysterious black box and learn about the ways that even the most convoluted tasks that can hopefully be as simple as they can for agents by giving them the right context. We want to give them the right context. So we're going to dive into the real world problems that we see when doing agentic development. We're also going to dive into some techniques that are commonly used for context engineering, as well as agentic architectures using knowledge graphs. And then finally, we're going to talk about different white papers, research, and courses that you can all take in order to learn more. All right, so let's start off with a real world problem that can actually apply to all of us. So most of us work in software, and so we are all prone to incidents, right? So we're all prone to incidents, security vulnerabilities. So picture that you are on a team and you get an alert, all right? So you get an alert that says suspicious activity on host X, production is down. Every engineer's literal worst nightmare, like, please don't make me deal with prod being down. So it's all hands on deck right now. Sev 1, customers are being affected. Production is down, and minutes and even seconds matter. So your team must decipher which machines and which services are actually at risk, how an attacker might move through a specific network, and then which fix will contain and then terminate access from this specific host. So slow or wrong answers is going to allow this attack to continue to spread, and we need accurate responses now. So to get as much information about this alert as possible, one of your teammates feeds that specific alert text into a generic agent, which then returns a generic checklist, right? Start a log, isolate the host, restore service. Easy, right? Easy peasy. We've done it all before. Super simple. No. What are you talking about? It is not easy, right? But this specific result is noisy, right? This specific checklist, it does not tell us which systems that we need to isolate, what are the services that are most critical, and whether the reported process is trusted. Now, I know this is not a cybersecurity conference, but I want you to go with me with the flow on this one because I'm going to get into the meat of everything, right? So that was actually just wasted time, right? Generic agent plus incident equals good luck. I don't know what to tell you. Good luck, right? So your teammate says, no, wait. I'm an AI engineer. I'm just going to figure out the right prompt, right? Oh, my God. Your entire team throws up their hands. Everyone gets back on their keyboards and like, we're actually going to try and manually fix this because we don't have time for whatever you're trying to do over there. Let's freeze time, okay? Let's freeze time. Hold up, wait a minute. So what actually went wrong here, right? And more specifically, the question I want you all to answer is, how could we have built that particular agent in order to be actually helpful in this particular scenario? So the problem was that the agent was giving us generic advice instead of immediate steps rooted in context. Context engineering. This is where this really shines. So context engineering, I'm sure everyone knows, but it's the discipline where systematically providing models with all the relevant information, tools, and instructions that it specifically needs in the correct format at the correct time to accomplish a particular task. So unlike prompt engineering, where you're going to try and say the right words to an LLM in order to get it to do whatever you want, manipulation, context engineering actually centers on building dynamic systems that assemble, complete, and structure context for each LLM invocation. So this shift in focus from cleverly worded prompts to a comprehensive context design is why context engineering is now considered a critical skill for AI engineers. And there are so many different techniques and practices that we can use in order to improve context relevance in agentic development. And it includes these 5 key areas. So RAG plus hybrid search is a key area for improving context. We can use memory management as well. We can try and structure and order that context. We can use tools and function calling. And then we're really going to dive into what knowledge graph augmented context looks like. All right, so just to go over quick things. So the classic approach, right, naive RAG, is going to use a vector database of embedded documents, right? And it's going to perform a semantically similarity search to find texts that are related to a specific query. So we all know this. It's perfect for single hop, right? Single hop questions where the answer likely resides in one chunk of the text. However, pure vector search is actually going to retrieve sometimes off-target information, right? Which is going to result in context poisoning, which is then going to lead to those wrong answers and those hallucinations that we see so often. So we try to combat this with RAG plus a hybrid approach. So we combine vector semantics with symbolic filters, keyword or metadata filters, to ensure that relevance. And you can also use techniques such as re-ranking, for example, to retrieve a larger set of data via the embeddings, and then a second model or heuristic to rank which contexts are actually the most relevant. And many practitioners also use contextual chunking, for example, where we're going to take a more hands-on approach to deciding how to split up and label knowledge, which can preserve the meaning and improve retrieval. And then this can also help you get more context-aware embeddings. But there's a trade-off, right? You have to take all of the time that it takes to decide what those splits and what those labels are. So then we turn to another method, memory management. Some people are like, memory management is the solution, right? So when an agent interacts with a long session or across different sessions, it accumulates all of this information that it needs to remember. So we use techniques such as sliding window or recency-based memory, which is when you drop the older history to prefer some of the most recent context history. And the trade-off is that your agent loses the important details that it has deemed older. So you can use, to try and fix that, you can use summarization of that history, maybe even episodic history, global state memory, for example. But all in trying to manage memory is going to involve deciding what we're actually going to forget here. So ultimately, effective memory extends the agent's context beyond the fixed window while avoiding the overload. And that's a huge benefit. That's a huge benefit beyond what we have now, and which is a generic agent giving you basic knowledge without context. So we can also use structure, context structure and ordering. So Anthropic, for example, has given us guidelines for long prompts, right? Place the most relevant information at the top. So that for that prompt, where the models are going to pay more attention to the beginning of that context window. So you're ensuring that the context that you give that agent is in a consistent format, like always using a delimiter or a label for tool outputs, or a fixed template for memory versus a new query. So, or we can also use context optimization or context length optimization. And all of these are within structuring and ordering that context to try and get your agent to work smarter. Before I get into the last one, I want to talk about tools and functioning as another method, which so instead of stuffing your context with raw data and instructions to do complex calculations, we can offload those tasks to tools. That's a great way to do context engineering. So for example, instead of giving the LLM a large table and asking a question just about that generic data, which would consume a lot of context tokens, it might be better to give an LLM a database query tool, for example. And then that agent can then execute a query and get summarization results to feed into that context. By specific use of those tools, we keep the agent focused on reasoning while offloading that heavy lifting. But the method that I really want to dive into today is using knowledge graph augmented context. So knowledge graphs are an extremely useful and powerful tool and way to introduce structured relational knowledge into agents' context. And unlike the collection of text chunks, a knowledge graph encodes facts within the relationships, right? So this is a network, for example, a network of different connections, and that enables this multi-hop reasoning that the agent or the retrieval system can traverse and then link information to gather the related context in a simple step vector search that a simple step vector search might miss. So we see here, for example, apple is a fruit. We can do various hops, and that information is very human readable versus the vector version or the vector representation of that data here, which is apple, we have the embedding, orange, the embedding, and then the fruit, the embedding as well. So in other words, graph can answer what is relevant about this query text. Not only that, but also what else is connected to this specific topic that is necessary to include in my query. So this means that your agent's context can include things like A is related to B via X. And this helps us understand the larger context and the larger picture. So we should take our data that's, for those who are a fan of tables and rows, that's normally formatted in tables and rows, and use tools to actually transform it into a knowledge graph. This example of network data, for example, and then customer data that is joined by multiple different joins, where you'd have to try and figure out what are the relationships between that data. So instead of having that tabular format of data, we should transform it, and there's lots of tools out there to do this, where that data is now clear, right? Where that data, the data and the ways that that data is connected is also very clear. So that your agent can then hop from one node, which is the circle, one node to another node of information to be able to trace and explain how it got that particular answer. And from an architectural standpoint, the way that we're seeing this shake out in engineering teams is as follows. So at the bottom, you'll see that we have our existing data platforms, right? The Snowflake, Databricks, relational systems, other relational systems, for example. And on top of that, we could have a knowledge graph. So that is going to connect all of your structured and unstructured data in a consistent and semantically rich way. So from there, you can use GenAI applications and LLM orchestration layers like LangChain or semantic kernel or different agentic frameworks, which can plug in and then access all of that data contextually, right? This is where graph as context and GraphRag fits in, right? It's about how you retrieve grounded contextual information from your graph. And this is what the agent architecture could look like when you're using a knowledge graph as well. You normally have the agent itself in the right column in the center, and then you could use a UI, which is pictured right above that, to expose the agent as a knowledge assistant. For example, for semantic search, automation, or personalized experiences. So you have the AI models themselves as well in this architecture, which is either an embedder or an LLM, and then which is pictured in the left column. And then you also have the data sources, which is pictured at the bottom. And you can use that for retrieval. It could be both structured and unstructured data. And then that data gets ingested into into a knowledge graph. So then that agent can then access the knowledge graph through tools like MCP, Model Context Protocol, which right now is the golden standard for connecting tools and context to the language models and agents. And it can also access other forms of source data as well. So the benefit for agents is that by adding knowledge graphs into the pipeline, when paired with an MCP architecture, the schema of the knowledge graph now provides so much context, right? When we break down a user's question or a prompt that they would normally input into a system, you start to see very clear and direct logical flows of information. And if we take this even further, in some instances, because of the increased context provided by the knowledge graph, the agent itself or MCP tool architecture can even get rid of using vector search entirely for retrieval. And that's due to the accuracy that you get and the domain knowledge that you get with adding knowledge graphs into your agentic workflows without relying on semantic search. So therefore, AI agents become more capable as their understanding of the world improves. We provide a more accurate, structured context for our agents. So on the left, we have a vector or keyword search, which is excellent for retrieving fragments. And in the middle, we have entity modeling, which helps identify different types of objects for your data. But it's only when we have that explicit model, where we're explicitly modeling relationships, that agents can begin to reason. So think about, for example, a contracts use case, right? So with just search, you might just find a paragraph that's in a particular contract. And with entity modeling, we might detect clause types, which is very helpful. But with a graph, you can start to begin to ask questions like, which US companies have non-compete clauses that are perpetual, and who else is involved in those contracts? So the level of reasoning that artificial intelligence needs, and graphs start to enable that reasoning ability. So in this specific use case, right, the impacts of the answers that our agents are responding with using knowledge graph augmented context continues to be well known as well. So in this example specifically, we asked our system which asset managers are vulnerable to a lithium shortage, right? So vector-based RAG, again, gave general answers, while graph-based RAG gave us a concrete list of asset managers who would be implied in this specific session. So graph-based context output was able to traverse specific nodes and edges and then connect the dots. So it understands which companies are using lithium, it identifies which asset managers hold positions in those companies, and then it reasons across that in order to produce traceable, accurate risk profiles. And then even in a medical use case as well, we look at the following query. What is the care plan associated with Andrea Jenkins emphysema? So let's see what this looks like in these specific examples. So we have here a patient has emphysema, and we're trying to figure out what the care plan can look like. So a direct call to the LLM is going to be very vague and provide you generic text. A vector RAG pipeline, which is more beneficial, but it gives us grounded info, however that information can be incomplete. And then when you use graph as context, or graph RAG, you can then combine vector retrieval with structured connections to surface precise treatments like smoking cessation counseling, rehab exercises, and medication regimens that are specific to this patient. So the graph makes logic explicit, and which condition, which care plan, which specific treatment that we need to look at for this particular patient. So once agents have the necessary context in the structure of a knowledge graph, we start to see the benefits. So using a knowledge graph as context has shown to improve accuracy, right? Let's look at the data. So across multiple different industry benchmarks, graph context consistently outperforms over traditional RAG. So we have ZEP-AI, for example, in this context, the graph RAG for AI agent memory improves accuracy over 18%. And then it reduces latency by 90%. Then LinkedIn as well, when we have a white paper that we'll talk about it. LinkedIn cut down ticket resolution from 40 to 15 hours using graph and graph RAG. So these are just various examples of the impacts that using graph as context has for building AI agents. And then some as well, we have different benchmarks. Let me make sure. Okay, great. All right, perfect. So we have some benchmarks as well. So the major difference, all in all, between these and the ones that were preceding was that they don't compare RAG, but instead they're comparing against LLMs without RAG or some other academic benchmarks, and we still see the impact through the graph context. We keep going, everyone. So graph improves context by boosting accuracy, improving explainability, and then future-proofing your artificial intelligence systems. All right, so I'm doing a lot of talking, right? Prove it, right? Nyah, prove it. So this seminal white paper, which was done by a staff software engineer, Zhentao Zhu, and his team, titled Retrieval-Augmented Generation in Knowledge Graphs for Customer Service Question Answering. So this paper tested graph RAG and graph as context to see if it benefited the customer service question answering process. And then they found that by including knowledge graphs into their RAG pipeline, they saw a decrease in per issue resolution time by 28.6%, which is a significant improvement for vital customer support. And then this is another white paper as well from the Microsoft research team in the office of the CTO. So it talks about the benefits of using graph and graph RAG over traditional RAG for query-focused summarization with LLMs. And then another interesting white paper as well, and I'll have all these resources at the end, is where this particular research used a knowledge graph retriever and what they called a covert neighborhood context as property to do retrieval. So I just wanted to give you all the resources that are helpful for you. All of these resources can be found at graphrag.com/appendices/research. And if you want the slides at the end, I'll be able to provide that as well. Okay. Well, thank you so much, everyone. It's been a pleasure. I appreciate you.